Bobby Stats.
Welcome to Unit 5, the last unit of the semester.
You and your singing.
Okay, so today's lesson, super duper easy. 5-1, introducing statistics. Isn't that weird that we've just now introducing statistics?
I guess so, yeah. It's weird. I mean, like we've been doing it all semester.
Yeah, and so the question, overarching question here is, why is my sample not like your sample? What do you think?
Well, and we'll figure that out. But we also want to talk about our learning objective, that we are identifying the questions that the variation suggests in the statistics, and we're going to look for samples we're going to collect samples from the population and see why they aren't the same.
Mm-hmm. So our essential knowledge, there's a ton of it in this one.
Oh my
Variation in statistics for samples taken from the same population may be random or not.
Not all things are the same.
Okay, so let's look at...
I thought you were being snarky. I thought there was a lot. I thought I was going to have to Mr. Bobby eyes a lot of things.
No, one. There was one.
One thing. Okay.
Easy lesson.
I fell for your snarkiness.
Okay, so let's just look at this really quick, because the overarching question here is if we're talking about a population, why is every sample not the same, right? Why is there variation when we pull a sample from a population, okay? So let's say I flip a coin 10 times and count the number of tails. Would I get the same result every time?
My guess is that it should come out 5 and 5. I mean, that's the way I would think it should come out. So if I flip my quarter here 10 times, I should get 5. What are we counting? Tails. Okay, so let me zoom in on the tails here. I got like the little eagle here. I should get that 5 times. Now, I'm not going to be shocked if it's 6 or 4. Okay, but it could. I mean, it could be like even more. It could be like only 1 tail. I could get, old George 9 times. It could happen. Okay.
It could happen. If it happened, we would be a little shocked though, right?
We'd be a little surprised, but so she's got here 10 flips. Oh man, I got to start flipping. 1 tail. Oh.
So I'm going to flip 10 coins 1 time. I'm going to hit go. Okay. And so what do we have here? How many tails did we get? We got 3 heads. So that means...
Oh, shoot.
I got a 0.7. I'm going to have to take notes here. I'm going to pick my handy dandy pencil up. And
so you got 7 tails. I got 6 tails.
You got 6 and I got 7? Okay, so
yep.
We got a 0.6 and a 0.7. All right, let's do it again.
I'm not doing that again. That was stressful.
Okay, so this time we got 5 and 5.
5 and 5. So wait, you're making notes or am I making notes?
I'm making notes.
Okay, you make notes.
All right, this time we got 4 tails, 6 heads. 4 tails,
4.
6 heads. Yes.
So we've gotten a 4, we've gotten a 4, a 5, a 6, and a 7 so far, right?
Okay.
Is that right? Am I right?
Yeah.
Okay.
This time we got 7 tails, so we got another 0.7.
Okay. Now 7's a little bit more than I expected, but like I'm not ready to. I don't feel like I need to call the cops on you on this website.
Got 0.7 again.
Now I'm a little leery. All right. Now I'm starting to get worried about this website of yours.
So I got what?
All right. Now I'm suspicious of your website.
I'm also suspicious. Why are we suspicious of our website, Mr. Bobby?
Because you keep getting more tails. You got. Now there's a 3 that's kind of balancing it. You see how she was getting more tails than I expected. I was expecting 5 tails and she was getting more than that. And so,
5.
And now it's kind of balancing. So on a short term, something funny could happen, but if it happens many, many, many times, then I got to, now she's gotten 6. Okay.
I'm going to go a couple more times here.
Okay.
0.4.
And so she's getting some that initially she had some 7s and 8s that made me a little leery, but now she's getting some 4s and 3s. And I think you had some 5s in there.
Yeah.
You lost me a little bit. Okay. Because I'm here gabbing away and I was flipping a quarter and my watch buzzed at me. Now we're weird. Ooh, a 1. But could that happen? I said that could happen. We could get 9 Georges. I think I actually said that. Or did I say that?
You did.
Yep. Okay. And she's done this a bunch of times.
Yeah.
Oh, there's what I expect. Okay, now I feel good. Okay. But if I'm looking at one trial, that's probably not enough. Okay. This is the many. So how long do you want to sit here watching us do this?
Not long.
You probably don't want to spend the rest of your life watching us do this. And I don't even know how many times. I think you probably only did it 10 or 12 times.
Let's see. I did this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 times. Ha!
17 times. That's not even enough, but so how many, so I know you got 1.10.
I did. Aw, heart.
Yeah, I'm going to use stamps instead of hearts. How many 0.2s did you get?
None.
None. How many 0.3s did you get?
3.
1, 2, 3. How many 0.4s did you get?
3.
1, 2, 3. How many 0.5s did you get?
4.
And that's the one I would hope that had the most, but it probably didn't. How many 0.6s did you have?
2.
What about the 0.7s?
3.
Any 0.8s?
1.
Any 0.9s? You did have 1. No. Okay. This is the one that set me off a little bit. And you didn't get any, I didn't check, but we didn't get any 0s or 1s, did we?
Nope.
Okay. So now, even that small number, 17, doesn't count as many.
Nope.
Does it? Okay. Is there like a threshold for many?
There's kind of a magic number here. The magic number really is 30. And this is one of those like weird things where it's not like, ooh, there's this sneaky mathematical reason. It's like people have been doing statistics long enough that they realize that usually about 30, you start getting a true picture of this population.
And what we were saying is I was kind of expecting this column to be the most frequent, and it is. If I were to describe this distribution, I would say it's roughly symmetric. It seems to have a center around 0.5. I'd have to worry about the spread a little bit. I'm not sure how to figure that out yet. Well, we did that with the NP and all that stuff before. But I could imagine drawing a curve over this if I could draw. Okay. And it being roughly symmetric. Granted there's, the 0.1 and the 0.8 aren't balanced, but, we're not like having a conniption about how spread out that is.
Right.
So, okay.
So when we talk about why is my sample not like your sample, the answer is because in real life, when in the short term, you're not going to get things that are exactly the same because it's random, right? And so that's why the many comes up, is because even if there are a few that are weird, like 0.10, after we do a whole bunch of them, we see that is a weird one, right? And so is this 0.10 random, or do we begin to suspect like we're using a weighted penny or a faulty software program? Well, how do we kind of decide if we think that there's some other variable in play that's messing up what we expect to happen?
I think I lost my quarter. Now I'm poor.
Aww. So what do you think? I feel like this was not faulty, not a faulty.
No, I don't have it. I have concern about this one, but it's 1 out of 17. The majority of the time, it fell in a reasonable range. I'm not sure that you found the greatest website in the recorded history of mankind, but I don't have enough evidence to say you've found me some sketchy website.
Right.
Granted, yeah, you never know. It's on the internet. Anything on the internet can be sketchy. So.
Truth. All right, let's look at another one. So we were looking at proportions here, right? the proportion of times I flip a coin and I get tails. It's also important here that we understand, and we talked about that, you know, this works with means as well. So let's say you're going to go buy an 80-acre Christmas tree farm because you really love Christmas trees. See, isn't it beautiful? Isn't this a beautiful farm?
Nice farm, but
yeah,
the humbug.
You'd like to know how many trees are on this 80-acre farm. Do you want to count them?
I know you guys think, oh, 80, that's not a lot, but do you understand how big an acre is, like land-wise? That's a lot of space, okay? And by the time you finish counting all the trees, somebody's going to chop one down because it's going to take you all year. It'll be Christmas and they're going to harvest them.
True. Christmas will be done over, and you will still be counting.
And it's not just because this is we're recording right around Thanksgiving. Okay, they're going to be chopped out.
True.
Okay.
So what are my options then in terms of like getting a rough estimate of Christmas trees on my new Christmas tree farm here?
What I would want to do is I would take a few samples of land and count the number of trees on that and use that as a model for the entire. So I would select a plot and count just that one plot perhaps, and then see how many were on that plot, and then figure out the ratio from that plot to the full land.
Yeah.
Okay. But I might want to do that a couple times.
Yeah. And why might we want to do that a couple of times? Why not just do this one plot right here that I drew this trapezoid on?
Boy, you look like you didn't pick. There's like some bald spots there, pathways maybe where cars where they would drive the tractors up and down the lines or something.
Right.
And you didn't got none of that area. And and there's probably like some, I don't know, maybe there's a pond on the there's probably a source of water on the farm, and then there's maybe a house and stuff. There's areas on this land probably that aren't covered in trees, or just parts of this that just don't perform as well as others. There's areas in farming that just don't work, and when that happens, you have to you're going to get less numbers. So
this sample is beautiful. If I use this sample to estimate my entire farm, would I get an overestimate or an underestimate?
My guess is you'd have more overestimate, because it looks like what you've highlighted there is fully forested.
Right. So you just have to be careful. And this is why, again, this is why we many, because not every sample is going to look like the population. Okay. So if you're not careful with your sample, your variability or your average begins to look wrong because of your poor sampling. Okay. And that's really what this lesson is about, is just understanding that when you start looking at samples and you're sampling and then you start estimating based on that, you want to make sure you understand that there is going to be variability, which we've talked a ton about, and that not all samples will look like other samples.
And they're going to be, they're going to be spread out and distributed just like anything else. So,
yep.
All right. Look at you. You got nothing to do.
I bet you're excited. Okay. Bye, guys. Thanks for joining us.